Now we are going to discuss more about input transducers. Let us consider this circuit. As I told you that LDR depends on brightness of the surrounding, and then let us try to consider this situation. In bright situation, the resistance of LDR is low. So what happens is, when resistance across LDR is low, then the voltage across LDR also will be low. Let us put some number here to make sure that we understand more about this. Let's say the voltage supply is 6 volt. So the low resistance, let us put one number here, for example 2 volt. Because of low resistance, so the voltage across it is also low, so 2 volt. So R must be 4 volt. So the output voltage is 4 volt in this situation. So what happens if we change the situation? Let's say that during in dark situation, resistance will be high resistance. So resistance of LDR is high, for example. So when the resistance is high, then the voltage across it will be high also, for example 4 volt. So the voltage across R will be low, for example 2 volt. So the output voltage for R is 2 volt. So that is how it works, and it goes the same way for this circuit. In a hot condition, resistance is low. Let's say we put number here 6 volt, for example. So during hot situation, the resistance across the meter is low, so voltage across the meter also low. For example 2 volt here, so it should be 4 volt over here. So the output voltage is 4 volt. This is only example, not necessarily 4 and 2, can be any numbers, because thermistor changes its resistance according to temperature. I just give you number 4 and 2 just for the only example, because 4 plus 2 becomes 6, to make it easy for me to explain to you. But I just want to show you how the output voltage will change depending on temperature for this circuit, and how output voltage changes depending on LDR for this circuit.